Matter.js, a 2D physics engine for the web that enables us to build useless things like Plinko, pinball, and an endless ragdoll torture stairway. Useless though it may be, I had to build something for myself. I first ventured into Matter.js with a click the button, get a spicy pepper demo, which is arguably the most useless application of a physics library that I've mentioned thus far. The first foray revealed to me a few things. Matter.js is a great little physics library, though the documentation can be difficult to sift through, and the boilerplate starter code leaves a lot to be desired. In this video, I'll show you how we can code our own boilerplate that is responsive to browser size, easier to debug, and reusable for your later awesome projects. It's pretty easy to get something on the page. I'm just going to fire up a new Webflow project here with nothing in it, load the script via CDN. Now we want to open up some script tags, and then we'll get the boilerplate from the Matter.js GitHub page and copy and paste it right into our project. This gives us a nice canvas right on the body there with a width of 800 and a height of 600. We want our canvas to be responsive, so let's start by dropping in a new div called Matter Container and give it an ID with the same name. That needs to have a width of 100%, a height of 100 viewport heights, and overflow set to hidden. We definitely don't want to write our code in Webflow, so let's copy and paste the boilerplate into a code sandbox file, and then we'll just import it back into Webflow. Let's start by getting a reference to Matter Container using document.querySelector and pass the ID of Matter Container. We'll change the element from document.body to Matter Container, and we'll pass in an options object where we set the width and height of our canvas to the Matter Container client width and Matter Container.client height. We'll also adjust background to be transparent, wireframes to true, and show angle indicator to true. We can see that the canvas is taking up the whole screen, though we still need to adjust the ground and the bodies themselves. Looking at the boilerplate, we can see that the code for the boxes and the ground is all hard-coded with strict pixel values. We'll go about trying to change this first. In the documentation, we see that the code for matter.bodies.rectangle takes 5 parameters: an X position, a Y position, a width, a height, and an optional options object. Something we want to be aware of before we start changing these is that the coordinate system is XY plane that starts with 0, 0 at the top left. Additionally, the body's referenced from the center of the body. So in this case with a circle, we can see that the XY coordinate is in the center of the circle and the radius emanates from that center. Knowing this, let's set the ground X coordinate to container width divided by 2, the Y coordinate to container height, and width equal to container width. We'll leave the height at 60 pixels for now. Things are looking better, but remember how we said the origin is in the center of the body? We can make the ground perfectly level with the bottom of Matter Container by declaring a variable called thickness with 2 C's and all caps and set it equal to 60. We'll replace the hard-coded value of 60 with our thickness variable and half of thickness to our Y coordinate. Now the ground is sitting where it ought to be. Let's make sure we adjust the canvas width and height on the browser resize event. To do that, we can declare a function called handle resize, inside of which we will set render.canvas.width and render.canvas.height to our desired values for our responsive Matter Container. We also ought to make sure the ground remains in the center. I didn't find a great way to adjust the ground width equal to the container width, so instead opted to just reposition it and set its overall width to something ridiculous like 27,184. So we've got these boxes, but we can't do anything with them. So let's code in some mouse interaction. We're going to pull more boilerplate from the examples. Create a variable called mouse, which equals matter.mouse.create, taking in the render.canvas as an argument. Next, we'll set up a mouse constraint, which accepts our engine, and an options object that has our mouse and a stiffness constraint. We still need to add the mouse constraint to the world, which we'll do with this composite.add method, which has a parameter of engine.world and the mouse constraint. Our world's getting more fun as we can pick up the boxes and fling them around. Let's go ahead and turn off the wireframes and the mouse constraint visible indicator so that things look a little bit more solid. If we throw our little boxes off of the screen, our little physics scene becomes not fun again, which nobody likes. So let's wall those things in. Right under our ground variable, we'll define left wall and right wall. Remember the order of function arguments from bodies.rectangle? Me neither. Back to the documentation. Okay, so it's X position, Y position, width, height, and options. Left wall X position is at 0 minus half of our thickness. Y is at matter container.client height over 2. Width is thickness, and height is matter container.client height times 5. The right wall is the same, except X position is at matter container.client width plus thickness over 2. And don't forget to add these to the world so that now we are all walled in. Remember that resize function? Yep, we gotta update that as well now. We can just do it for the right wall. We'll call matter.body.setPosition again and update it to where it needs to be. 2 boxes isn't enough. Let's add some circles. We can set up a for loop and use that to add 5 circles using bodies.circle. Similar to rectangles, the first 2 arguments are x and y, but the third here is the circle's radius. Let's say 30. We can pass some options of these circled bodies as well. In fact, this is where a lot of the fun comes in with Matter.js. You can vary friction, air friction, and restitution to create some really wacky materials. I like bumping up the restitution, which is basically bounciness, to something like 0.8. Check it out. I'm feeling like we definitely need more than 5 circles. But before showing you how far we can go without breaking this thing, there's one last item on our list to build out a better boilerplate. Let's hop back into Webflow and add a spacer div up top such that our Matter.js section is not above the fold anymore. And also we'll put it side by side with another div inside of a flex wrapper just to show you that we can. Pretty neat, huh? It's super responsive. Look, if I scroll while hovered over the canvas though, the window goes nowhere. This can be really disorienting to the user. Luckily the fix is pretty easy. We'll just remove the event listeners for mouse wheel and DOM mouse scroll that are included automatically by Matter.js. Once we drop this code in there, we can scroll past now and back up. Let's remove all that now and break this thing. I'm gonna push to 100 circle iterations. Okay, now that I feel like we're on the path to some good clickbait, I feel like YouTube has tried to show me this 10,000 agents do stuff in Unity video a million times, but I ain't clicking. I got standards, like 500 iteration standards. Let's blow this thing up. Oh, look at that thing go. We need 1,000. We need 1,000. Save, refresh. Come on. Ooh, look at it go. It's chugging. Look at 1,000 balls. There they go and they fall. And we can mess around with them. Man, Matter.js is fun. Hey, if you enjoyed watching that and learned how to build better boilerplate, then you should subscribe and like this video. It really helps me out a lot and I really appreciate it. Yeah.